Okay, welcome to another episode of our lesson. Today we want to look at friction in this episode. So friction is the force that opposes the relative motion between two surfaces in contact. It has its advantages and also its disadvantages and its uses. So first we are going to look at the friction on a horizontal plane and also friction on an inclined plane. Let's start with friction on a horizontal plane. So we have a body with a mass, and then we apply a force P on the body, and when we apply a force P, there is a force opposing the motion, and that force is called friction in the opposite direction. And this body has a weight W, which is mg. That's the mass times acceleration due to gravity. So from here we can calculate the coefficient of static friction. That's the friction of the body when it's still at rest, just about to move. Coefficient of static friction, let's call it mu s here. So mu s is equal to the frictional force F with all over the weight W, or let's start with R, reaction R. But here R is equals to W, and for static friction our P is equals to our F. That's why we can use F here. So this is going to give us, if I change this R to W, I'm going to have F all over W here. Or I'm going to change the W to mg, I'm going to have F all over mg. So if you are asked to find the coefficient of static friction, is the applied force, the force that is being applied divided by the mass times gravity. This is the applied force. F here is the applied force. Remember, since the applied force is equal to the frictional force, but in opposite direction, all over the weight of object, or weight of the body. So if we cross multiply, let's say I want to cross multiply the first case here, I'm going to have that my frictional force is equals to mu static friction times the reaction, or we can say that mu static all times mg. That's this one. Anyhow you want to use it. This is for in the case when the body is still at rest in the horizontal plane. But when the body starts moving, so whenever the body starts moving, the applied force would be bigger than the frictional force. That is to say, the P is now greater than F. P will be greater than F because it has overcome the static friction and it's now in dynamic friction. So for this case, we are going to find our net force. Fr is our net force here, which is going to give us P minus F, the applied force minus the frictional force. And our Fr here is equals to the mass of the body times acceleration. Remember, the body is in motion, so our net force here is going to be the mass times the acceleration. Let's look at the second case when the body is now moving on an inclined plane. When the body is now moving on an inclined plane, so this is the inclined plane, and we have a body with M, has mg here, has an angle, has theta here also. We have here, when we resolve this M mass, we are going to have mg sine theta over here, and then we can also have the height here, h, and distance d here. Alright, so from here we can find out that our coefficient of static friction, remember we start with static friction, the body is still at rest, has now started moving in that inclined plane, is equal to, remember, our frictional force all over the normal reaction. But in this case, the frictional force is gotten as mg sine theta all over our normal reaction here is mg cosine theta. So if we cancel the mg sine theta and cosine mg out, we are going to have sine theta all over cosine theta. And remember, sine theta over cosine theta is what? Tan theta. So remember, what is tan theta now? Tan theta means opposite. So if this is our theta, tan theta means opposite all over adjacent. So if we know the height of the inclined plane divided by the distance from the height to the ground level here all over d, we can also find the coefficient of static friction using that case. Okay, but let's look at when the body starts moving. So from here, first I'm going to cross multiply. When I cross multiply, my frictional force is equal to mu s r. Okay, when I cross multiply, my frictional force become mu s r, or I will say mg sin theta is equal to let's change the mu to dynamic now. So this I'm going to have mu s mg cosine theta. Okay, so if we bring this guy to this other side, so we're going to have mg sin theta minus let's put it's now in motion, k mg cosine theta is equal to, remember, if it is in motion, it is equal to the mass times the acceleration. From here, we are going to factorize mg out, so we are going to have mg into sin theta minus mu k cosine theta is equals to ma. Since m is common on both sides, we can remove the m, and then for this side we divide each term here by cosine theta, or let's say we factorize cosine theta out. So if I bring out cosine theta, I'm going to have g cosine theta into, remember, since I remove cosine theta from here, I'm going to have sin theta all over cosine theta. So that if I multiply this inside, I'm going to be left with sin theta minus mu k only here. Remember, factorize cosine theta out is equals to the acceleration. So the acceleration of the body here, a, is given as g cosine theta into, now remember here we are going to have sin theta divided by cosine theta will give us tangent theta minus the coefficient of dynamic friction. That's how to find the acceleration of the body in this case. The body on an inclined plane, when we are given the dynamic friction, you can find the acceleration of the body by multiplying the acceleration due to gravity times the cosine of the angle that is given into the tan of the angle minus the coefficient of dynamic friction. That's the end of our lesson. Thank you very much for watching. I'll ask you to like, comment, and also don't forget to share. Thank you very much for watching.